Hi, we are now in Module 2, Quarter 3, and in this module, you will be able to demonstrate understanding of the use of different ways of expressing concentrations of solutions like percent by mass, mole fraction, and or percent by volume. Also, you will apply your knowledge of expressing these concentrations in the making of salted egg. And then at the end of this module, you are expected to create a detailed recipe of salted eggs. So prepare the materials and ingredients you need to prepare for your salted egg, which will be salt, egg, and water. Then prepare a computation of your proposed salt solution. Take pictures of your preparation from computation of salt solution to salted egg tasting. And then conclude in 7 to 10 sentences the importance of basing your recipe to the quantitative measurements instead of the term tantiameter. So this is the last question provided in activity 5. Attach in this module the pictures of your preparations to salted egg tasting. And then please read carefully the rubrics given for you to meet the highest possible score, which is 30. Then activity 1 is your review of computing for the moles. Readings 1 is determining molar mass and mole fraction. Read and understand this reading for you to be able to answer activity 2, which is an application of determining the molar mass. In problem number 2, you may check this link or you may just search in YouTube these terms highlight as demolition explosives for you to have a visual representation of this problem. And then for readings 2, solution and methods of concentrations. In this module, we will focus on these 3 mentioned concentrations, which is mass percent, volume percent, and mole fraction, which I will discuss. The focus of this module is expressing solution concentration in various units. So we have an example in our module. An ethanol water solution is prepared by dissolving 10 milliliter of ethanol with a density of 0.789 gram per milliliter in a sufficient volume of water to produce 100 ml or 100 milliliter of a solution with a density of 0.982 gram per milliliter. What is the concentration of ethanol in this solution expressed as volume percent, mass percent, and mole fraction? So, you write down the given. So, you have 10 milliliters of ethanol, the density of ethanol, and then 100 ml of solution, and the density of the solution. So, list down the required percent by volume, percent by mass, or mole, and mole fraction. And these will be our working equations. Let's start with volume percent. Since you already have volume of solute over volume of solution, you can directly substitute these values in this formula. Then, which will give you 10%. So, this means that you have 10% by volume of ethanol in a 100 ml solution. So, let's take for B. To start with percent by mass, you have to find the mass of the ethanol and the mass of the solution. You can find this by using the given density. Density, it has a symbol of rho. So, density is equal to mass over volume. So, to derive the mass, we multiply both sides by volume. In this side, volume will be cancelled. So, you will now have volume times density is equal to mass. So, let's substitute the mass of ethanol. You have the 10 milliliter. 10 milliliter of ethanol times its density of 0.789 grams per milliliter. So, milliliter will cancel out. Mass now is equal to 7.89 grams. This is for ethanol. Now we get the mass of the solution. So you have 100 ml of solution times the density mass of the solution is equal to 98.2 grams. Substituting these two values to the given formula, which is mass of solute divided by mass of solution times 100. So, 7.89 grams divided by 98.2 grams times 100 will give you 8.03% of ethanol. Please correct the answer in your module. Okay. Now we go to part C, mole fraction. So I left the two values in here which we will be using for the computation of mole fraction. So as mentioned in your module, so first we should convert mass of ethanol is 2 moles. 7.89 grams of ethanol to number of moles. Number of moles is equal to mass times the molar mass of the substance. we will substitute the values of mass and the molar mass. Molar mass is the sum of the molecular weights of the present element in this substance. For ethanol, the molar mass of ethanol is 46.07 grams per mole. This will be our conversion factor for the number of moles. We have the mass, 7.89 grams of ethanol. We will use this as conversion factor so we can reverse this value as 1 mole over 46.07 grams of ethanol. So grams will be cancelled. You now have the value of your moles, which will be 0.171 moles of ethanol. Now, number 2, determine the mass of water present in 100 milliliter of solution. So, from your mass of solution, 2 grams solution minus the mass of ethanol, which is 7.89 grams of, which will yield to the grams of or the mass of water. Number 3, convert the mass of water to the number of moles. So, we'll use this formula again. So, mass of water is 90.3 grams times molar mass of water is 18.02 grams per mole. Again, we can invert this value by 1 mole over 18.02 grams of water, which will give us a value of 5.01 moles of water. Grams will cancel. We now have the number of moles of solute, which is your ethanol, and number of moles of water, which you will use in the denominator of the mole fraction. Using this formula, using the formula of mole fraction, amount of component in moles divided by total amount of all solution components in moles. So, this is not identified as solute because you can also use this formula for solvents. Okay. Since our required is mole fraction of ethanol, we will use the amount of ethanol as the dividend, and the total amount of solution or the number of moles of ethanol and water as the divisor. Is equal to total amount of components that is required, which is the ethanol, divided by total amount of all solution components, which are the ethanol plus water, which will give you an answer of 0.171 divided by 5.181. So mole fraction is 0.0330. This is your mole fraction for ethanol. We now have expressed the solution concentration in various units of ethanol in percent by volume in a 100% solution, in a 100 milliliter of solution, and 8.03% by mass in 100 milliliter of solution, and 0.0330 as mole fraction. Thank you. Activity 3 is the application of your readings 2. Follow the procedures of the examples for you to be able to answer these exercises or these activity. Activity 4, this is the procedure of your salted egg experiment. So, objective, materials, and procedures are already given. And for the computation, this space is for the computation of your percent by mass and percent by volume of the salted egg. Densities of salt and water is also given to complete your computation. And then activity 5 is the guide questions to be answered to conclude what is the importance of quantitative measurements. For questions and inquiries, clarifications, don't hesitate to message me. Thank you.